Mark May the 21st and 2nd in your diaries for the 40th Birthday Retro Festival 2022, taking place at the Centre for Computing History in Cambridge, England. Celebrating the 40th year of some of the most amazing home computers released way back in 1982. The event will feature exhibitors from the retro computing world, including friends and colleagues. Oh, and of course myself as Wi-Fi Sheep. But that's not all. There will also be the Centre for Computing History's amazing in-house exhibition content and hands-on displays for what is going to be an absolutely fantastic day out. Full details, including tickets and pricing, see links at events.wifisheep.co.uk. Hi everyone, how you doing? And a very warm welcome back to youtube.com/Wi-Fi Sheep with me, Tom. Now, I'm really excited to be able to do this video finally. It's been in the works for way too long. Today, we're going to look at another microcontroller, and we're going to look at something called the ESP32. Now, I have briefly mentioned this on the channel, and it may have featured in another video if that video comes out before this one does. All depends on the timeline, but just for the benefit of everyone who's brand new, let's just assume you haven't heard of the ESP32, and so I can just introduce it as new. So what is the ESP32? Well, it's a microcontroller chipset devised by a company called Expressive Systems, which are based in China. Now, a lot of the chip architecture we use, so things like ARM or x86 or even the old Motorola 68000 series chips, all derived either from the United States or from Europe, in the case of ARM here in the UK, regardless of where the chips were actually made. The ESP32 chipset is interesting because it's actually one of the sort of early ones that actually comes native from China. And as far as low-powered, RISC-based microcontroller chipsets go, it is extremely powerful, and it's only recently been challenged by the introduction of the ARM-based Raspberry Pi RP2040 chipset, which is used on the Pico or Pico microcontrollers. So personally at the moment, because ESP32 has been out for 6 or 7 years already, there's a lot of libraries and fantastic resources and tools available for it, so I actually prefer it over the Raspberry Pi Pico. So what exactly is it? Well, as I said, it's a Arduino compatible microcontroller. It runs in 32-bit mode. Most of them are dual core, and it's a custom ESP32 micro 32 chipset. The thing is extremely powerful. Let me just run you through some specs here. So, as mentioned, it's a 32-bit RISC architecture. It has 4 megabytes of flash ROM capability. That's huge for a microcontroller. Its active static RAM is 512K. Bearing in mind, things we've been using for our Tiny Basic Computers project, for example, we've been dealing with like 1 or 2K. This thing has 512K of RAM. That's huge. I think it's actually more than the Raspberry Pi Pico. It runs at a clock speed of 40 megahertz. Bearing in mind, we've been running around 16, anywhere between 8 and 16 megahertz on our other chipsets. So to be running at 40 is fast. And best of all, it has a lot of support and one fantastic library available for it called the FabGL library, which contains a number of really useful and very cool retro emulators. That's right, the ESP32 is powerful enough that it can actually emulate classic 8-bit and even some 16-bit computer systems. Today we're going to look at actually using a board to run DOS IBM PC compatible software. It's going to emulate an ATX86 chipset. That's one of the very early Intel chipsets from the sort of 1981-82 era. And it's even possible we might be able to get a graphic user interface, which is an early version of Windows, to boot on this thing. So it's really, really impressive. And that's what we're going to look at right here on the channel today. So this is the Arduino Nano, and I'm sure you've seen us use these multiple times over. Nice little 8-bit microcontroller, 2K of RAM, and I forget how much it can store. It's like 26K of storage space, something like that. Anyway, so there's what we've been using pretty much to date. And in here, I've got a ESP32, which, as you can see, similar sort of microcontroller, a little bit bigger in size. Now the ESP32, as I mentioned in the introduction, is considerably more powerful and considerably more storage capacity, and it's actually a little bit bigger. What I did forget to mention was that these things also have built-in Wi-Fi, which is also really, really impressive. It's also 2 buttons on top of this particular version. And these are both fine. We'll take the Nano away. The ESP32 is fine, but it does suffer from, if you want to do anything additional like video out and like that, it's powerful enough to do it, but it is a bit of a pain to have to wire up everything individually on pins to build circuits. And sometimes when you just want to emulate stuff, you want a better solution. So, straight from China, in this packet here is a different type of ESP32. Let's open this up. And here it is. This is the TTGO ESP32 VGA. And basically, it's this chip, but on a complete self-contained Arduino style board, but it's no board you've ever seen before. So we have a VGA for video on this side. We have 2 PS2 ports for mouse and keyboard. We also have I think that's 5 volts out there. Was it 3.3 volts out for a fan, if I remember correctly? We've got a headphone jack for stereo audio, and we've got a micro SD card slot here. So there's quite a lot going on this little board, and I think these things are absolutely fantastic. Now, in order to use the capabilities of this, you do need PS2 compatible mouse and keyboards. If you have a keyboard that can run the PS2 protocol, even if it's USB, you can plug in, for example, an adapter. And in my case, I actually want to put this into the keyboard adapter. And I do actually have an Acer. These are new old stock Acer mice that have the correct PS2 protocol end, so we can plug that into there, and then if I plug a USB keyboard, will go into here. As long as it has the PS2 protocol, that'll work fine. And obviously VGA will go into our VGA monitor or adapter, whatever we happen to be using at the time. So in order to make this work, we do need to flash this with something, and to do that we need to plug the micro USB into our PC, Mac or Linux box based machine. So I have a mini to micro adapter, and I'm just going to pop it on the end of this mini USB cable. That will go in, get it the right way around, in like so, and we'll plug this end into, in this case, a Mac, and I'll show you how the libraries work. So, good morning. It's the following morning from when I first shot this video, and I'm about to save you a whole heap of time. So the original plan was I was going to use a Mac to flash the TTGO ESP32 VGA board, and it was all going so well until I hit a snag, which was to do with the USB to serial controllers that these boards now use. Now, because of the national or international chip shortage, the controller chip on these has changed. And unfortunately, the Macs, whatever you do not like the drivers. So, never mind, I thought. I'll switch on to a x86 tower machine I've got that's running Ubuntu Linux, or Ubuntu Studio. And that got so far, but then that had problems because it then didn't have the correct terminals and God knows what else. Okay, I thought, so we'll switch on to try Windows 7. And that failed as well. Again, driver issues. So the only thing that did actually work, and I tried this last night before shooting today, was a Raspberry Pi 400, which is the all-in-one Pi-based computer, running a fresh, brand new boot of Raspberry Pi OS, the 64-bit edition at time recording. And that has worked. So what you need to do is get yourself a USB-A to micro USB, and I've got an adapter here from mini to micro, and we'll plug that into our ESP32. You don't need at this point an SD card in this because we're flashing straight to the NAND, 4 megabytes of NAND memory on board. So we'll plug that into the Pi. There we go. Okay, so here on a fresh install, you need to install the Arduino IDE. It's quite simple to do that. I'm not going to show you how to do that in this video, but basically we've got IDE installed and we'll execute in 64-bit mode running on a Raspberry Pi 400. This actually runs quite fast. Now, for ESP to work at all, we need to install a set of libraries. So the first is the board library. So if we go to File, Preferences, there's an additional boards manager here, and let's just click. So this is the link you need. This is for a .json or JSON file. I'll put this link in the description of the video. Just copy and paste it into this space here. Click OK and OK again. Then from Tools, we go to Board Manager. By the way, you do need to be connected to the internet for this to work. And we want to search for ESP32. And here's the Expressive Systems library. Now, I've already got it installed, but what you'll do is you'll click to install here. Make sure you are running the latest version, which at time recording is 1.0.6 or later. So this is already installed here, so we've done that. Then what we need to install the FabGL library. And to do that, we go to Manage Libraries, again under Tools. And we want to search for FabGL. There we go. Again, depending on how fast your computer is and how fast your internet connection is, speed of this may be a bit slow. Here's the FabGL library, and again, I've got the latest version installed, which for this is version 1.0.5. That's the library we need. So I've already installed it. You click to install here. And again, this could all take a few moments to do. So once you're done, you can actually load up the PC emulator sketch. So we go to File and Examples, and right down the bottom will be FabGL. Now, if you haven't got the board selected, it may come under a pop-up saying unsupported. So it'll be unsupported FabGL, then VGA, and PC emulator, which is this sketch here. And that is the entire emulator, all bundled, all ready for you, including a BIOS, a ROM. It's all here. It's very, very clever how this works. So now what we need to do is set our board up. So we want to select board, and it's under ESP32. Oops, ESP32. And I've already got it set here. It's TTGO T7 V1.4 Mini 32, which is the correct board. Now this is very, very important to make sure under partition scheme, you need to have this selected to huge APP. Okay, if that's not selected, this doesn't work. Finally, the port. Now, the port can be a bit tricky sometimes. You want to set it to TTY ACM0. So I've got two showing up here, so it might be on the wrong port, but let's just do a check. So if we can ask for, we go Tools and Get Board Info, and there it is, so it does show up. Sometimes when connecting these boards for the first time, you need to hold down, there's a tiny little button here, which is sometimes called mode. It's not labelled as mode on this, it's called IO36, which is this button here. And you need to basically unplug the board, hold this button down, and then plug the board back in whilst holding this button, then let go, and that will initialize this and allow it to show up to the Pi or whatever system you're running. If you don't do that, you can have problems. So with this all done, we can either verify to make sure it goes through fine, and then we can then click to upload, and that will upload it to the device. So hopefully we're now ready, and this is working and uploaded. Before we can test it, we need to add a few things. So we've still got the USB cable here attached, and we'll plug that into a 5 volts power source. I've got an iPhone charger, that'll be fine, so we'll get that plugged in shortly. So you can see what happens on the screen. I've got a VGA to HDMI converter. That's so I can plug into my capture card. But you would normally just plug a normal VGA monitor. Or if you haven't got a VGA, then you'll need one of these adapters. So we'll plug that into there. It does need its own power, which will give it via USB. And if you wanted to, you could actually capture the sound as well, because there's a headphone socket. So that will now put both picture and sound and convert it to HDMI, which is really useful for what we need. Now, for this to work, we do need a micro SD card. That's not because it needs to run like a Pi and run all the software on this. It's purely because it's going to download and upload stuff to the card so it can run the emulators and any software we want to add. So this is in standard FAT32 file format. Do be careful because the cards are very vulnerable to snapping because they're not covered by the PCB. They sort of hang off the side. So do be careful with that, whatever you do. And then finally, before we power up, we need to add keyboard and mouse. And our board should be more or less ready. So hopefully you're seeing the rainbow test card screen. So let's power up and let's see if this actually works. So what you'll see is, for the very first time, if you haven't booted already, is you'll see a screen asking you to put your Wi-Fi details in. That's right, these boards actually have Wi-Fi built in. And if you connect your Wi-Fi, you'll then get this list of configurable machines, each of which can be downloaded directly from the FabGL server and added to your SD card. Now, I've gone ahead and already installed quite a few. You see there's various operating systems, MS-DOS, there's games packs, all sorts. Interestingly, we've also got Windows 3.0 and we've got Gem. So we've got a Gem 3.13 here. This is slightly later than the Gem that we used on the BBC Micro. If you remember back to that video, we used the Raspberry Pi to emulate a 286 Intel chip, and we ran Gem 2. Well, this is Gem 3, so let's run. So we can click to run. And this will boot a FreeDOS system for us, or in this case actually MS-DOS it's going to start. It flicks quite a few screen modes because it boots into Hercules mode. Well, I believe it's Hercules mode, or perhaps not on this. And there we are. There is a full working Gem desktop, which is kind of cool. It's a little bit clipped on the top, but hopefully you can see that all right. And it mounts as a hard disk that we can double click. And there's all sorts of things on here. So we've got, for example, Gem Paint. You notice that the mouse driver works as well. And you'll probably remember this. This is the same Gem Paint that we ran on the BBC Micro video. And only runs in black and white on this, by the way. But it runs quite smooth. It's not laggy. Yeah, I don't know why I keep doing art programs. I can never paint anything remotely decent while I'm showing you these. But you can see it works fine. And we can quit. Yes. Now, because this uses .img FAT format disk images, means if you take the SD card, you can put it into a Mac PC, whatever, mount the image and add to it. So I actually added on a Mac my favourite game for testing, which is HeliSim from Sierra, which we used a number of times, and we ran it on the BBC Micro. Here is exactly the same software. So here's a .exe, and we can open. And this will put the machine into CGA mode. There we go. Aspect ratio is all over the place, but we are running, and I think we can hit escape. We can go into demo mode. I think we are getting some very faint sound through as well. Yeah, I don't know if you can hear that. I can hear that. There's sound coming through. I might just put the volume up so you can hear it. Yeah, that's a PC rendition of a helicopter type sound. Frame rate is absolutely abysmal on this. It's worse than it was on the BBC Micro, but hey, it's running, and it is possible to run. So there might be a shortcut for getting back to the main menu. I've not found it yet, so I'm just going to do a reset of the machine. It always checks the time and date because it finds my Sky broadband router, which this is connecting to. Okay, there we are. So I think the one you've all been waiting for. Let's look at Windows. So we can hit to run. This is Microsoft Windows 3.0. These are all pre-packaged for you, so you just have to download them once you've got this up and running. It's extremely impressive. And this does run in Hercules mode, which is going to give us a very strange aspect ratio. There we are, Microsoft Windows 3.0. So it's going to look correct, because the Hercules, I think, goes into a kind of a pseudo 16:9 widescreen aspect ratio. So it's going to look correct, even though it's not, if that makes any sense. I don't know if it does, but you'll see what I mean in a moment. Okay, sort of correct. I think the capture card is slightly skewing the image. It's a funny resolution this is kicking out in. But there we go. There is Microsoft Windows. It's not 3.1, it's version 3, but version 3 and 3.1 were 9 identical to each other. You only get it in this black and white mode, but it's there. We've got Paintbrush, which I was showing on Twitter last night. Bearing in mind this is running as an 8086, so it's one of the very first PC chipsets, so it's slow. But once it's up and running, it's up and running and it's okay. Let's just see how smooth that is. Not as smooth as Gem was. Yeah. And of course you've only got black and white modes. Gosh, I remember this used to be the prime graphics program that we used when I was at primary school, when we eventually got some PCs in. And they didn't replace the BBC Micros we had, they just ran alongside. But yep, that seems okay. And then of course when we're done with our Windows session, we can exit Windows. Don't bother saving changes. Okay, one final thing I'm going to show you is, I can find it, is MS-DOS or DOS programs and games. I have already installed this, so we'll just hit to run. This is using the FreeDOS kernel. And if we now, got to remember your DOS commands, dir. We've got basic on board, but we've also got games, so we should be able to, if we go CD games, it's that again. Got some games on the system. We've got Pit Stop 2, so I should be able to simply say Pit Stop 2. Again, this is all pre-installed, just have to download them. And there is, in a slightly strange CGA mode, Pit Stop 2, so we can have a quick game. Remember correctly, this just uses the cursor keys. Oh, we're off. Oh, we have got some sound going on as well. So I'm the one at the top, and then the computer's play at the bottom. And yes, this is sort of as eyesore-y as and of course the aspect ratio is all completely wrong. This should be in sort of square 4:3 mode. I can actually get past my competitor who's blocking me. There we go, I've now appeared on the bottom screen, managed to do an overtake. And this runs okay, but it's designed and optimised for the slow processor speeds. And of course we're not trying to run a full graphical user interface on top of DOS. But anyway, you get the idea with how this works. So lots of games to look at, and of course, being as it's a full PC emulator environment, you can add your own disk images, you can add stuff to the SD card. Works really, really well. And you have to remember, this is a microcontroller. There's no Linux or Pi underneath, having to run an operating system, then running a DOS box on top. This is all just running effectively bare metal against the ESP32 processor. So it's extremely impressive and very flexible, especially if you want to create emulated systems that are not basically Raspberry Pi in boxes. So there we go. That was the ESP32 and the extremely impressive FabGL libraries available for the Arduino IDE. That I think is going to be fantastic, and I look forward to doing future projects right here on the channel. It's well worth if you can get hold of one of the TTGO ESP32 VGA boards. Those things are so useful and saves you a lot of time. Well, I've really hoped you enjoyed this video. Don't forget you can find out a lot more about me and what's going on with the channel by following us on Twitter. It's at Wi-Fi Sheep. That's at Wi-Fi Sheep on Twitter. If you haven't done so already, please do consider liking and subscribing. And as always, I hope to see you real soon right here on the channel. Until next time, bye for now.